All right, so the update for today, it's 9 something. I just got done talking to Brandon for like a million hours. So I haven't really done anything. I got absolutely no sleep. My stomach is killing me right now. Um, but I'm also hungry. That's the weird part about all of this. Um, and it's raining, and I'm tired, and I don't want to do anything. Oh yeah, that's where we left off yesterday as we were following along with testing from signals. And so I messaged somebody, didn't get any help with. I don't think that Vector BT does the thing that I was talking about. Oh, yeah. So last night I was thinking I need to actually write out on paper what it is that I need it to do because I think it's going to be a bunch of for loops because there is a section of run combos for to get your entries. Then there is all of this stuff. Testing leverage mode, testing order type, testing size type, testing leverage, max equity. Doing all of that stuff that Octobot did. Um, and so I'm thinking that we'll probably have to do something to where you use. Oh yeah, I was supposed to check open folder footprints. Pandas footprints. What? Convert tick data to volume data. This is definitely not the thing. Is this what it was? There's no way that this is what it was. Is this what it was? Or was I working on this? What the hell? There's no way this would work. You can't do this and this. So I know there's no way that's the real thing. But I do remember this. Well, fuck it. Let's just try this. Uh... 6 seconds. Oh, I remember I was maybe trying to do. Takes 3 seconds. Now it takes 6 seconds. Now it takes 3 seconds. Well, it has to run it first. Interesting. So here, this IMDb, IMB candles. This needs to be an empty, and then when I get all the way down here, I can just kill off all the rows. So I was looking in here for something. I think it was I was looking into this because yeah, because what I need to do is have like a for loop for the coin. So if I have Bitcoin and Ethereum, I wish I could just I wish I could just write. So I guess maybe if I did this, well, I guess I might as well switch back over to this. Well, I guess maybe over here. So if I had BTC and ETH data, then I would need 4 coin in range length coin. Then so that would be dealing with like the coin number 1. Then if I had RSI below 20 and 14 period, and so below 20 and 30 and 14 and 15 and 20. So that would give me 1, 2, 3, 4. So that would give me 4 possibilities. So then inside of here it would be for RSI setting in range RSI.shape 0 or something like that, right? So then those would be the entries. So this would. So now we are in Bitcoin, and then now we are in RSI setting number 1. So we're in coin. So that's RSI setting. Then inside of here, we would say for order setting in range order. So here it would be like stop loss 2, 1, 2, and then take profit 2, 3, 4. Our risk to reward. And so that means that there's a total of 3 times 2 is 6, and then this is 4. 4, and this equals 2. So we're on Bitcoin, we're on RSI setting, we're on coin 0, RSI setting 0, order setting 0. Right? And so that means that we would need to do process order, and then we would say if RSI entry 0, right? Then process the order, and then would say no, here we would have to create the order. So order equals order. And then here, that's where we would use the order settings. So we would say stop loss price equals order setting. So here we would have to, so it couldn't just be this. It would have to be not 0. Anyways, I gotta think about this. This is why I just need to write this stuff down, because typing it is too much right now. I just need to be able to scribble ideas. Actually, I think that the way this works is the run combos would be combo Run comms. So I think the way this run comms works is you send it the price. I could have sworn to God there was a tutorial that did run comms. There's a tutorial. Hmm. All right, so I think the entries you have. Yeah, so you have your fast window, your slow window, and then you have your. So here I'd have to run this again. Let me see. So I still have my walkboard optimization that I did. If this should just work then. I swear to God it was longer than this. This isn't just like a. Is this just a copy? Wait a minute. Hmm. Anyways, so what I have to first do is download the data from a coin. Then from there, I need to take that coin and apply the RSI from combos, I guess. because here, this run combos, he only talks about it once here, and then he also only talks about it. Let's see. I think he talks about it in. What? I could have sworn to God he talked about it somewhere else. Oh, yeah. He talks about it there, and then he also talks about it. And then he talked about it in the documentation. So, I guess on this mission, I need to understand how to do the thing where if I want to test, yeah, at first okay, so the first thing that I need to do is figure out how to download yeah. Yeah, I just need to figure out how to get multiple values for the RSI and turn all of those into entries. Yep. And then from there, I would have to do something to where it would be like where's my to do? There would have to be like a column. So this is rows and columns. So it would have to be row and column if RSI entry. So the column would be RSI 14 below 20. So the entry would be doing RSI what? RSI with the window length of 15 and then below 20, right? So RSI length 15, 20, RSI below 20, 30. This equals 4. So then we have our stop loss. So column 0 would represent 15 and 20. Then column 1 would represent 15 and 30. Then column 2 would represent 50 or 20 and 20, and column 3 would represent 20 and 30. And each one of these, 15 and 20, will have rows. Oh no. I think this is RSI shape 1. And then each one of so this 15 and 20 will have rows of however many candles are in this right here. We'll have as many rows as that, and that would be I guess that would be down here somewhere. And so each one of these would have rows of just false and true, false, true, false, true, false, true, false, true, false, true, false, true, of should we enter or not. And so this column gets this, like this. And then this row comes from here. And then this range I think this is a coin 1. So I feel like we don't even need any of this because this is going to be taken care of previously to get the entries, because it's like we have that already over here. So we get the entries from the combos, right? So we get the entries. Where do we actually use this? Oh, from signals. So we send it the price, we send it the entries, the exits, and the quarks. Yeah. So I don't even think we need this. Well, actually, we do need this. So we need this. So this is RSI. Well, this is the setting. And then the row is going to be, I guess it would be this. Because these are the bars. And this is the RSI. So this would be bar. So this would be if RSI entry. So we have our 15 and 20 here. And then we would be going through the first bar within this RSI to see if it's true or false. If it's, let's say that this is true. If this is true, then we come into this order, and then we have our stop loss, risk to reward. So inside of this would be like a gigantic table. It would be like this. It would be like this. So we'd have a column of stop loss, risk to reward 1 and 2. So we would say stop loss price, stop loss percent. What? How does this make any sense? Anyways, I gotta go take Max for a walk. Also, I didn't leave yet, and that's because I was doing the trying to figure out the for loop thing, and I feel like you have no choice but to do the broadcasting thing because then it just gets too complex. Um, yeah, you have to do the broadcasting thing where it's just uh the stop loss would get like 1 1 1, then it would get 2 2 2, then you'd have risk to reward as 2 3 4, then 2 3 4. Because when you're doing the for loop here, well, not here, but in another place, I would say here is where you do like you create the order. You would have to list the order, and then you'd have to have like stop loss 0, then take profit 0, then max equity 0, and then you come through here and you have your if entry, then you create your order, and your stop loss percent would be SL, right? So it would be this variable. And then your take profit would be this variable. And then you go through and you get all of your results. Then you come back up here and then you go to 1 and then you do stop loss 1 and this 1 and then this one. So then now your stop loss or your risk to reward here. And then now what you would do is you would now have you first tested stop loss 1, risk to reward 2. Then you come back up into here, you change it to stop loss 1, risk to reward 3 by going into 1 here. Because again, your stop loss looks like this: 1 1 1 2 2 2. And your risk to reward looks like 2 3 4 2 3 4. So now we started at 0. Now we're at 1. Then we go to 2. Then you go to 3. Then you go to 4. Then you go to 5. And that's the only way to do it. I don't think that there's any other way to do it if you had these things like all in the same. If you had all of these in like the same array, it would be too difficult. Yeah, it would just be too difficult. And so I have to figure out. So it seems like he almost probably already does that with the broadcasting. I just don't know. I have to mess around with the broadcasting to see exactly how it's done. Because here, we look at this. You do have this 1, 2, 3, then you have 4, 5, 6. But the problem is that when you broadcast, you end up getting this 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6. That's not what I need. And it also broadcast A, B, C. So it'd be 1, 1, 1, 2, 2, 2. If I could do this 1, 1, 1, 2, 2, 2 for the stop loss. So maybe if I just do it like this would be 1, this would be 2 for the stop loss, and then I would have 2, 3, 4 for the I might as well just try it now. Let's see. I might as well try it now. But I have to have to go up here and import broadcasting. Okay, so import broadcasting. And now let's go back to broadcasting. And let's see if we did this. But the other problem is that I don't know how many broadcasts that you can actually do. You can't just send it an infinite amount of broadcasts, I don't think. Unless I args to shape to for I in broadcast print I. Where is this at? Bring an array like object in args in the same shape as NumPy broadcasting. So let's just try this real quick. So we'll say stop loss, and then we'll say risk reward. So the stop loss is going to be 2, 1, and 2, and then that's it. I feel like this is going to say that I need the same size. 2, 3, 4. What? Oh. So then here, if we did SL RR equals broadcast SL RR. Shape mismatch. Object cannot be broadcast to a single shape. This is 111. 2, 2, 3, 4, 4. So it's doing it this way. There we go. But now the problem here, array-like object. I guess I have to look at this V equals 0, A equals this, SR equals PD series with the index, DF equals data frame with an index and a columns. What the fuck does this mean? Taking new index and columns from position, broadcasting index and columns through stacking, setting index and columns manually. I guess this is what I would need to do, setting index and columns manually. Might as well just try this. Oh. One, two, three, 0, 0, A, SRDF. What the fuck is this? How does it know what V and A? Wait, so does this mean that if you just do hashtag args that it'll allow you to just put in whatever however much of this stuff that you want? Can you do that? Can you just do like V V V V V V? What the hell? You can do that? You can just put as whatever you want? And then I can just put SR, 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 DF, 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 A. No fucking way. Oh my god. No way. Oh my god. What? Wow. Wow. Well, the answer is within this. So I gotta go walk Max and I'll come back and see if I can get it. So here we have something. It seems to be, if we broadcast, it would be like 0, 1s. Then we have the 2s right here. Then we have this. And then we would come back up and do the same thing. But then we also have this array right here, which doesn't really make any sense. If I had this as like 1% and 2%, this works. I feel like there's some type of math here that needs to be done. Because this does work, but then if I add another one of these things, then I have to have like deeper, and deeper and deeper and deeper. But the problem is like I don't know what the user is going to throw in, and so the problem becomes you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is there 13 different possibilities here? Let's see, if I have a risk to reward, if I have a 1%, well, let's see, we want to do risk to reward and we want to do max equity. So if we have this, then we have this, then we want to have our max equity at like 2, 3, 4, and 5. So what we have here this would not work. So what I need to do is grab this and say 1, there needs to be 1, 2, 2, 1, 2, 3, 1, 2, 4, 1, 2, 5. So that's 4 ones, 4 times 3 ones. Then I need 4 times 3 twos. And then here I need 2 times 4. I need 1 times 4 twos, 1 times 3 threes. Wait. I need 4 twos, 4 threes, and 4 fours. So I need 1, so this would just be so if I were to do something like this, it would have to be something like and then I would do okay. First I would have to create an empty, and I would have to have it in the shape of so this is going to need to be 1. So we'll need 3 ones, 3 times 4 ones, 3 times 4 times 2. I think that's what it is. We would need 3 times 4 times 2. So we need 24. We need 24 columns. 24 calls. And then after that, we would need one. So 24 divided by this. Then we need 24 divided by 3 of this. Right? Is that the way it works? So 24 divided by 2 of this. We'd need 24. So that's 12 ones. So that's 4 and 3. That's correct. 4 times 3 is 12. And then if we did 24 divided by 4, we would need 24 divided by 4. What is that? 24 divided by 4. We would need 6 twos, 6 threes, 6 fours, and 6 fives. So does that work out? So we would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we need this as 24. Wait, how do I do this though? Let's just see if the math is correct here. So we do stop. Oh wait. So then how do I need to just think. The secret is in this this run thing. This rsi.run, because you can send it where is that? Indicators, basic, run. Run pipeline. Yeah. I think I'm just going to stop recording until I figure something out, or like I notice something, because this is just too difficult. So right now I'm running this on the pro version, this run, because he basically did exactly what I want to do. You have this list here, and then you have this list here, and then it just does exactly what I need to do. 888, simple x Wilder 999. So you could literally just send this any list of anything. You can send it this list, you can send it this list, you can send it this list, you can send it this. You could, it seems to be that you could just send it multiple different lists. And then this run function, you just come in here and you go to the next thing. Well, no, that's let's see if we can do this again. Let's run into here. So this run function brings you, whoops. Let's do it again. All right. So it brings you to this run function, right? So this is the run function. Here, this gets everything, the information, and then it runs this pipeline. And that's the thing that I was looking at earlier. And then this pipeline returns the results. And then unpack results. Create a new instance. And then you return the object. And that's what you get. You get this RSI object. Damn it. So you have this object, which is exactly what it returns. But then it has to go through this run pipeline, and then this is where it just gets nuts. I mean, look at all this. This reminds me of the from signals thing. What? This is exactly what I want. Well, I don't need it to print out like this, but I just need it to do the 8 simple 8x 8 Wilder, 9 simple 9x 9 Wilder. And you could do that since it's RSI.run. You could do this if you had any other indicator that had like 5 different things. You could do that. But so this, thank God that this is taken care of. Now I have to figure out how to apply this same exact thing to stop losses and take profits and all sorts of other stuff. Okay, so we've made some progress so far. So if we have a stop loss of this length and a risk to reward of this length, then we have to get the total size. So this is gonna have to be like a for loop through all of every single possible thing that should be broadcast, right? It'll need to be a for loop of their length, right? Or it could be shape. I would just do length, I guess. Length of this times length of this. Right? So I guess it would just be times equals length. So it would have to start out as like 1 or something like that. Anyways, so this is just obviously the very beginning part. So we have the total size equals this. Then, so we get it that this needs to be a length of 6. So then we have our old, which is 0, and our new, which is the total size divided by length of stop loss. Then we create a temporary an array that's empty of which is the total size, because that's what we need it to be. Then we send it in a for loop of I for the length of stop loss. Obviously, again, we're going to need to for loop this whole thing. And then here we do temporary, which is old to the new, right? Which is going to be, this is 6 divided by 2, which is 3. And then boom, we have our stop loss. And so now if we applied this same exact stuff down here, so we don't need the total size. So now what we would do next is we would do RR and we'll just do delete temp. Oops. Well, we don't need that. And then we'd say RR, this would be RR. And this would be RR, and this would be RR. And this, we'd get rid of this. We get rid of this. So we run this, we get that. Then we run this. Ah, shit. Oh, no. We needed to say 2, 3. What? We need to say 2, 3, 4. It needs to say 2, 3, 4, 2, 3, 4. Oh, no, 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 no. 2, 3, 4, 2, 3, 4. 2, 2, 3, 3. Why does it say 1, 1? Huh. Well, I basically just got owned because this for loop only works for the first one. And then obviously afterwards, it just doesn't work. 2, 3, 4, 5. So it should be 2, 3, 4, 5, 2, 3, 4, 5. So I think I'm going to have to I'm gonna have no choice but to follow this down to here. Short name, params, hide settings, output settings, is instance. Do I do anything here? You don't do anything before that? RAM settings. Anyways. For kv params items, if instance v default params k value. Where is our data? Ah, here we are. Params. Oh, here we go. Split args. Args. There is no args. What? We do have args. How do we have args? Oh, args is this. How did it get that? I feel like we're skipping over something. How did it get that? So we have param names. How did we get param names? Oh, what? If instance hide param names is param names. How did we get param names? Oh, I guess that's part of the args. But how do we get args? Param names is here. names, split args, but that's here. Oh boy. Oh. Huh. Let's see what happens here. Well, somehow we get the args. So our args are this. So now let's go to the next part. It's up here. Inputs, dict, zip, input names, args, the length of input names. Check. Args equals arg, length, input names. What? So I have found where the thing happens. So as soon as you go create param product, make cartesian product out of all params. This is what I need. Cartesian product. So, because if I go all the way back over to here, and I debug this and this, go to the next, this, we don't do this, we don't do this, we don't do this, it's here. So you can see our params list is 8, 9, 10, 11, 12, 13, 14, all the way to 20, 0, 2, 3. As soon as I go here, watch what happens to params list. Boom. 8, 8, 8, 9, 9, 9, 10, 10, 10, 11, 11, 11, 12, 12, 12, so on and so forth. So it's inside of here that we need to go. Oh my fucking god. List map list zip itertools.product. Make cartesian product out of all params and params. What the fuck is this about? No way. Params list sequence params list zip map list zip itertools product params list. Oh no, what the fuck is this? I thought I found the Holy Grail. Can I go into this? Oh no, how? How do you do this? List map, list map, list, zip, itertools, product. What is this? Itertools? The fuck is itertools? Oh God, iter tools. Oh no. Iter tools. So here we are. Here, iter tools product. In the terms of mathematics, cartesian product of two sets is defined as the set of all ordered pairs where A belongs. The input array 1, array 2, output 1, 5, 1, 6, 1, 7. Well, okay. I don't know how the hell that works. Let's go through the working and use case of this Python library. Oh, cartesian product. 3, 4, 2, 3, 4 more. How to get the cartesian product of multiple lists? Yeah. No way. Is this really the thing? Oh my god. This could be it. Oh, I need to add my little style bot here. This could be the thing I've been looking for. This could be the thing. It could be the thing. Shit. Open stuff. Ah, shit. Lang py. Meta. Meta. So I think I need to do this. Okay. And then here. Built in. What the fuck does this mean? Built in print I. Oh, whatever. All right, let's try to come down here. Whoops. 2. Oh my god. Oh my god. Oh my god. So if I do SL, SR, SL, SR, SL, oh god. Wait, what? Why is it like this? 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5. Why is it like that? Is it because this just needs to be a list? What if I had 0.5 and then I had this as 1? I got rid of this. And I had this as 2, 3, 4, 5. It needs a list. Is it? Is it? Oh my god. Oh my god. Oh my god. Oh my god. I have found it. I have found le answer. So it seems to be that you can just put in as many things as you want. Cartesian product. How do you find the Cartesian product? Do a list comprehension, iterate over both the list and add the strings like. How to get the Cartesian product of multiple lists? The question already has answers here. Boom. Boom. That's insane. So what if I come over here and I do this and I say I have a list of 1, a list of 10, 4, 5, 30, a list of uh, oh my god. Oh my god. Oh my god. It. Oh my god. Oh my god, this is it. Oh my god. So then I would have to take this whole entire thing and put it into a NumPy array. And grab the whole first, or I'd have to grab this and then transpose it. And then I have to grab the whole first thing, the whole second thing, the whole third thing, the whole fourth thing. I have to grab all 5 of these, but oh my god! Oh my god! Oh my god! It's about to be a tuple. Okay. Wow. Wow. Congratulations. Wow, wow, wow. Congratulations. Wow, wow, wow. Wow, wow, wow. what is this called? Cartesian product formula. Let's see if there's anything on YouTube's Cartesian product. Anyways, we are about to take a break. Actually, I just realized that there isn't really math behind it. The math is 1 and 4, 1 and 5, 1 and 6, 2 and 4, 2 and 5, 2 and 6. My question now is like, I guess, how would you program that? Python program Cartesian product. Construct. One and 3. I guess what I'm trying to do is figure out list and tuple. List comprehension. So we have down here itertools product params list. Then you have the zip of that. Then you have a list. Then you have a map. Then you have a list. What the fuck? Wait, where was that at? Create params list. All right, here we go. Try it again. So we're here. Create product. Boom. Now we're here. Now we create it. And now we have our list. But why is it like zipped and mapped and all that other stuff? I think what you do is what? Can you do this? So you have to zip. You have to map. It's a map object? What? Oops. And then you have to create a list out of the map object. IterTools product will give you this. I wonder if putting that star in front does anything. So we have to put together a params list. So is the params list just a list of lists? Let's see what it is before we get there. Type param. It's a list. So I guess cartesian product numpy. So here, import numpy, you have an array like this, an array like this, result equals np.transpose, np.title x length y, np.repeat y, comma, length x. Multiple arrays. So you have arrays, LA length arrays, data type numpy dot result type arrays, array equals numpy dot empty length arrays for A in plus data type for I, A in enumerate P. Wow. Holy shit, this dude went through a bunch of things. Holy. What? I mean, seeing as how he is using all of this stuff and it's lightning fast still, and there's no numpy involved, I'm pretty sure I could just get away with doing the list thing. So we could just uh, do a for loop append to a list. And then do the Cartesian product. And then send all of that back. Yeah. Okay. Okay, I think I'm officially done now for this little section. Alright, so I'm officially pissed because clearly here it shows you. Let's generate multiple parameter combinations with thresholds, simulate them, and concatenate their statistics for further analysis. Itertools product here. Generate all possible combinations between lowers, and it's also called the Caspian product. This is what, if I would have just read the using loops, comb stats, test RSI, lower upper, for lower upper in the combs. Ugh. Wait, what? Test RSI. Test RSI. This creates a list of series. Well, I guess this is all I want to do, except with stop losses and take profits and all of the things. I need to be able to have like a but here we just have a list of numbers. But how do we know which row corresponds to which parameter combination? We'll build a multi-index with two levels, average, and make it the index of comstats df. Comstats df.index equals pd.multi-index from tuples. The combs names equal th combs. th combs. How is this possible? Comstats df. Oh. Dot index. Oh, so we're creating the index. Jesus Christ. Oh, I can't believe all of it's right here. Oh. So first you have to run something like this. I guess this is where I'd have to use polars or polars and do the same thing. So hmm. So trying to think of the process here. Anyways. Okay, so here it's looking like you run the combinations, then you get your entries, which is RSI cross below, whatever, whatever. And then you get this gigantic database that has 4,719 columns. And then it has 1,096 rows. So, man. Jesus Christ, there's going to be so many for loops. And so here you'd have to do entries.ilock, and then you'd have to have one. So this would be for shape, and then you get the columns. For I, for call, for column 0, because we want all the rows. Column 0, we want this, and then we want dot values. Well, anyways, here you have this. And then we'd have 0. Well, here we'd have to extract. Oh my God, we'd have to extract the values. Oh my God. So if we did entries dot values, so this is all of the. There's only 1,000. What? Ah! So here would have to be 0 and 0. And then here it would be 4,000. What? Index 4,000 is out of bounds for axis 0 with size 1,000. How do we access that whole other... How do we access... How do we access the 4,000? That's how. So we want to get all of the row values for 4,000, and then we'll do 0. And then we'll do 1. Then we'll do 2. Then we'll do 3. Oh my god. And then here we'd have to do 0. Oh my god. So here I guess it would have to look like 4. Can you do this? For entry in entries. Can you do this? So here we should have a length of like 10,000 or something like that. So this is the fall. This is the first one. So there's no way this is 4,000. Maybe it is. And we'll do I plus equals I equals 0. Alright, so that's the value, that's the rows. What? For column in range entries dot values shape. Then we say for entry in range entries dot value dot shape. That's entries, all the rows of the first column. Give me the entries. What does that mean? How is that not working? If I have entries dot about entries. Oh, that's why. Dot values. So this should be the same thing as this. Yep. Okay. Holy Christ, man. And then inside of that loop, we'd have to loop through all of the different possibilities of the stop loss times the take profit and all this other shit. So we could get into, even just with this, we have 5 million possibilities? Wait, what? Is that what it is? Is that really what it is? Eight, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. Wait a minute. This is 5 million possibilities already, and that's. Oh no, this isn't 5 million possibilities. This is just 5 million to go through. This is 5 million entries. So we have to check over 5 million entries. And so inside of here, it would be like if equals, if this is true, then you have to do order equals order, and then here you do holy shit, where would you put this for loop? I think you'd have to put the next for loop in front of this one for thing in range 6. Because let's say that you have a stop loss. Let's say that we have a stop loss is 1 and 2. And then we have the risk reward equals 2, 3, 4. So we have 2 times 3, which is 6. So here we say for thing in range 6, for call in range this, for entry in range this, we're getting the 8. We're going to start with 28 in simple. Let's test that. That's what we're doing here. Then we're saying if inside of that there is a true, then do the order of stop loss equals stop loss thing. Right? and then we'll do risk to reward equals risk to reward thing. And so this will generate a whole bunch of orders. And we'll process all of that stuff. And then when we're done with this, we'll go over to the next column, which would be this one, and we'll test that. And we'll just keep looping through that over and 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 over until we are done. And the price would be the open, high, low, close. So let's do this. Obviously, this is a million times slower because we're doing the pandas. But if we were to, actually, we'll do this. God damn, this is taking forever. Can I interrupt it? Okay. So let's store MP entries. Okay. So that's NumPy. So then we'll just do this. This. And let's see how fast this goes. God damn, that's a million times faster than pandas. Holy Jesus. Let's, whoops. Let's copy this. So let's do this. So we're going to test the speed of pandas. And then we'll test the speed of NumPy. Jesus. I think this one's going to probably take an entire minute. But the fact that this goes so fast is really, really, really good because then that means that we can test a shitload of stuff very, 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 very fast. So now the only problem is going to be how do I keep track of what is what? Because at the end of it, wow, 53 seconds versus 5 seconds. 53.6 divided by 5. Oh, that's a 10x speed difference. And you know what's scary about all this is that Guillaume was even slower than this shit. My God. My God. My God. And then if we did number with this, then obviously it's going to go even faster than this. So, anyways. So if I can figure out a way to do the Caspian thing, whatever it's called. Uh, Cartesian. If I figure out how to do this, with NumPy, and I copy this, let's just see what happens if I do that here. If I do this, ooh, whoa, 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 whoa. At ingit. Did I import number import ingit? np Can you do this enumerate shit in here? So how do I send it multiple array? Oh, okay. So then inside of here I can do this, and then I send it SL, and then SR, R. And then what happens? What? How's SL not defined? Oh. np.array. Why is this like that? So this is stop loss. This is, whoops. So I wonder if we did what? Loop tester. What? Oh. Four seconds. Here. This takes 5 seconds and this takes 4 seconds. Still shaved a second off. But how big of a difference is that still, though? So we do 5.2 minus 4.4 divided by 5.2. That's a 15% difference. This takes negative 10 seconds to do this. So what if I did a RRR? Damn! Oh, there it is. All right, so we know how to do this. We know how to do this. We know how to do this. So now all we have to do is put all of this together and have it make sense. All right. Because what? Do we do the Caspian product of an order? And then inside of the order, we grab the each array. So what? We would send it. How does that even work? All right. So what do we need to do here? We need to. Whew, I think we need to copy this. Go over to this. Come back over to here. Oh my god, all of this stuff. Wow, wow, wow. Testing Caspian. So we don't need where vector bt is that. Okay. What? No module named vector bt. How is that possible? What is this thing talking about? Okay. Let's vector bt. What? 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 Wait, what? Why the hell can I not have it outside of this portfolio? That is very, very weird. Why does this work? What? What? What the what? All right. Sounds good. Sounds really good. Sounds really good. Okay, this still doesn't make any sense. Okay. Let's just let's come over here and do a little restart, shall we? Shall we? Go ahead and do a little of this. What? 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 Anyways, I'll come back to this. That is so weird. This was set to Pro VBT still. Why the fuck was this thing still set to Pro VBT? That's weird. Okay. Anyways, I'll listen to some music and I will be trying to make this for loop thing happen. Oh my God, I'm still recording. So we did get the confirmation that array like equals true, or array like equals 0.0, or np.nan, or any of those things. Um, so now what do we do? I guess we go over here. And here we do order. I guess we do this. We duplicate this. Anyways, I guess I'll start recording once I find something significant, like I just showed over here, or I actually finish doing the thing. I just want to listen to some music. So this is very interesting here. So it seems like no matter what I do, because I remember last time, whenever I would send some information over and it wasn't exactly what Numba said, it would just yell at me. And so I'm not exactly sure what to do here, because I want this to be an array, but it seems like you can literally put anything that you want here. And then order array like, it doesn't seem to do anything. But over here, it's asking for these things to be an array. Yeah, like up here, it's asking it to be an array, as array, as array. Here, it's asking for a 2D array, but I also remember multiple times that I would just put in $100 for init cash, and it was perfectly fine. And so, it doesn't actually convert it over to an array. TP1, because I have that over here. I had this as TP array 1D. Save this. But it's going to do the same thing. But then when you come down here for the init cache, let's see. So we come down here. You don't have to do this array thing. You just put 100 and you have no problem. Or maybe that's because if I go here, signals. So close is array like. Type string float. Supports array type nd. Where is one where it's like you have to be a one-dimensional array? Type nd array. I just don't understand what is the point of. So here we can do array like. Then if we send over just $100, then we're gonna come over here. But I guess the init cache. So if instance init cache is an int and init cache mode, cache init cache string. What's today? Friday. I don't know. Anyways, I'm not sure if I need to change any of this to whatever it is, but for now, I guess we will. I don't know what to do. I guess it doesn't even matter. So, what does this mean? This means, I guess, that we go back over to here. Because even if I restart this, I do not have... I have this as ingit. So I don't know. I guess I'm just going to move forward and test out some of these array things. And if it works with just having float, then I guess it works. I don't know. This is making me wonder about the order checks. How does he handle this thing? Buy in B. Check against minimum size. Here. Execute order. Oh boy. Now I'm really wondering about all these fucking checks. I think all of those checks are going to have to be after it is split. Yeah, I'm gonna have to split everything, then run it all through the checks. So the checks will still work. So I'm gonna try to just basically give up on making this work because I kept getting this error and I don't know exactly how to fix it. But the main thing is like if I'm using, well, I mean that defeats the whole purpose of using NumPy. Then I might as well just use the iter tools and then use the product thing. Uh, so yeah, whatever. All right, well, I guess also I just need to make the shit, and then afterwards I can try to do whatever. Um, Ew. Where am I at? Where? What? Cartesian product. This is not a number function. So try length is this. And hmm. How does the iter tools work? Did I do it over here on the math part? Oh, iter tool. I wonder, could I do this? Could I? Oh, I have to send. So I think the process would be I have to create the order within the cart, and then so the first thing I do is create the Cartesian product. I'd have to do that first. Then from there, I have to write this down. So I think the process has to be you get the data first. Then after you get the data, you get your entries. Then once you get your entries, you have to put in your Cartesian product order. Then you get that back, and then you put the in values, and by that I mean Jesus Christ. So you get the stop loss 0, price 0, and you create your single order with this information. So you set a for loop, and then within that you go through and you get your information, and then you plug it into the order, and then from the order you go forward. And so it looks like with this over here, I think So the Cartesian order is going to have to take in all of the stuff that you get from here. It's going to have to take in all of this information and then do its Cartesian thing and then send it back as an array. Then send back all the things as the array that they need to be. Then from there, you go to another thing that will. So you send each one of these back as a NumPy array. Then you go to the next thing, which would be to create this order right here. But you'd have to have a for loop for that. So I guess that's where was I writing that stuff? Uh, test Cartesian. Here. So first I would get the Cartesian thing. Then inside the then after that, I send the information over to here. Then that gets turned into an order. Right? So this thing gets turned into an order. And then you go to the entry, you see if it's an entry, then if it is an entry, then you I guess that's where you'd create the order again. Why would you create the order here twice? So over here you have order dot. So you have your order. So we've gotten our order from somewhere else already. And all we're doing is just changing the price here, which we got to take price out of this order thing. And so here, yeah, so this would make sense. So the Cartesian thing would take care of it, and all of this stuff would just be order dot. So we'd get the order from the Cartesian thing. And then all of this stuff would be order dot. So this part would be right down here. And then we'd pass that off to the process order NB, and we would do all of that stuff, and then we'd come back up until we get kicked out of this. Then we'd go up to the next value, and we'd run it through that, and 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 that. And then when we're done with that, then we come back up here, and we go to the next thing in the Cartesian. So we go from 0 to 1, and we'd load up all of those different changes. And then we would go back to the process again, and then we'd come back up, and we'd load up all those changes and go back to the process again. The only problem is that the Cartesian thing is not number. And so I guess you can still have a non-number function inside of this number thing here. I guess that's fine. But maybe I need to find another way to do the Cartesian. Whoa, what? Numba implementation 5 times faster than using iter tools. Oh, that size. Actually work? It doesn't work. Python arrays do not have that size attribute. There is a line that says arrays equal mp dot as array x for x in arrays, but not in the JITted version. So if you pass in a Python list, it should throw attribute error on line 3. The function body. In the JITted version, what is this guy talking about? Well, fuck it. Let's see if this works. Let's see if this works. Wow, wow, wow. Well, there you go. This works. What the fuck? 9 years ago? Wow, wow, wow. Wow, wow, wow. Well, there you go. So now, I guess, how do you add to a tuple? I wonder if so hear me out, hear me out, hear me out. So if we do not know what this is, we'd have to do try this, then we'd have to do can you have an array of arrays? Like, can I have np.array sl r sl? Like, I want hey, there we go. But then how do we do that over here? If we have this, then we're going to go through, we will grab but then how do I know which ones? Oh. Um, damn it. How do I know? How do I know which ones of these is an actual thing? I'd have to store it to a list or uh oh wait, what am I doing? Oh yeah, I've got to figure out how to get all of the ones that are actually arrays. So I mean, in order to just save all of this time, I don't want to take up a bunch of memory because if the thing is like, if this thing gets massive, then if we have a bunch of these rows and then we have like this as a 6, then this as a 7, then this as an 8. And this is a whole bunch of unnecessary memory. It's going to be like 40 of these things. That's just and it could get massive. I mean, so in order to reduce the giganticness of the size, I have to be able to figure out exactly which ones are arrays and which ones aren't. But I don't know how to append. I mean, I could just simply make an empty array of 40, which is a very, very, very small thing. So I could do temp equals np.empty. And then I could just do length of order, right? np.empty 40. So we do that. And then here we would just store the index. So if this actually works, then we store the index of I in this index thing. And then so we have so then here we have index equals 0. And then here we would have idx index equals order I. Oh wait. Equals I. Right? And so we would get the indexes. And then after that, fuck. Oh, it says here, list or tuple of arrays. 1D arrays to form a Cartesian product of. List or tuple of arrays. So that's a tuple. And this is any. So oh, this is tuple. So could we do this? Tup equals SL RR SL RR. Maybe it's a tuple of a tuple. There we go. Fuck. Well, how do we get that over here? After we're done and we have this. Then how do we create a tuple out of that? Well, I guess you could just do this. So if we have an array, numpy array, SL or R. What? Cannot construct a D type from an array? What? What? Oh. I guess this is what it is. And then you do tuple. Can you do this? Hey. Map. I don't know if you can do this map stuff. Tuple. This. Can you do that? What the hell is the difference? Oh. Oh. Well, you just do this. Okay. Oh. So here, we just do this. Tuple np.array. And so inside of here, we have this array that's empty. I don't even need this length thing anymore. Just try this. So array is this. Index IDX is this. IDX. IDX. So we just have this empty array of 40 or whatever it is. Then we have IDX equals 0 for I in range this. Order equals length order. So we have this. Then for I in range this, we do this. What? Equals this. Then at the very end of it, we just do tuple array like this. And then after that, we do this. We change this to like that. Oh, wait. Arrays equals this. So we get the length of the order, we get the array empty. Oh, shit. And then we'd have to do this all the way up to IDX. Because let's say that there's 2, right? We're just doing stop loss and take profit. So we have this as 0. So then we come into here, we get that, and then it turns to 1. We come back up to here. We come here. This turns to 2. So then we come down here. We're going to go from 0 all the way to 3. So that means that we're going to go to 2. So we'll do 0, 1, 2. No. So we'd have to do this -1, like this. For I in range this. Do. Because this would do 0. Because here all we would do is just do 0 and 1. So we'd want to do, but this would be 0. This would turn to 1. This would be 1. Then this would turn to 2. Oh, then it would kick us out at 2. So then this is actually right. Because it'd be 0. Come in here. 0. Then this turns to 1. You come back up. You get the second one, which is the risk to reward. So the first one was stop loss. So stop loss is 0. Risk to reward is 1. This turns to 2. This is from 0 to 2, which is going to be 0 and 1. And then you pop out. And then so after that, I guess you can just delete R. Because we don't need it. Well, I guess it gets deleted after it. Oh, so it only lives inside of. Yeah, it's not even that big. Well, I mean, it could get massive, actually. Okay. And then here is where you would do all this stuff. And then I don't know what to return. And so I think all of this would work. I think I'd have to return the indexes of the orders that anyways, time to go to sleep.